Andarki namaskaramulu. Today we are going to start with Vedic mathematics by Dr. Goutham Mukherjee ji. I will briefly introduce him. After prarthana, after paying our respects to our country by chanting Vande Mataram and then prarthana. Before that, I want to say that this course is being run by Veda Samskruti Samiti in association with Vishwayoga Vidyapeeth, and we have already finished 5 weeks of coursework in which we have studied or learned what is the importance of Sanskritam and introduction to its grammar. Then we went on to learn Vedas, Vedangas, and then Dharma Shastras. Then Dr. Prabhuji has taken Upanishads, Darshanas, and we had one lecture from Ayurvedic on Ayurveda and Indology by Kishorji. Then we had one or two lectures from on Sanatana Dharma by again Vishalakshi Garu. Side by side, every Friday we are learning Sanskritam. 5 classes are over in that, are completed. Now going forward, we are going to learn Shodasa Samskaramulu from Vishalakshi Garu and Mahabharatam from Nagaraja Rao Garu and Ramayanam from Padmanabha Rao Garu. Like this, there are some more small topics, like though not small topics, but 2 lectures by on Panchangam by Sundariji. These 2 classes will be on Saturday and Sunday. The dates I will tell you. Now, with this introduction, let us request Salla Chittibabu Garu to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam, Sufalam, Malayajasitalam, Sasya Syamalam, Mataram, Vande Mataram. Subrajyosna pulakitayamini Pullakusumita drumadala shobhini Suhasini Sumadhura bhashini Sukhadam varadam mataram Vande Mataram Vande Mataram. Namaskar.
Vande Mataram. Now let us request Sharada ji to chant Prarthana, please.
Sarvebhya mama namaskaraha. Harihi Om. First 1 minute meditation. 3 times Omkara Japam. Om Gananam Tva Ganapatikim Havamahe Kavim Kavinam Upamasravastavam Jeshtarajam Brahmanam Brahmanaspata Anasrunvannoti Bhisidi Sadanam Om Sri Mahaganadhipataye Namaha Om Prano Devi Saraswati Vajebhirvajinevati Dhinamavitravatu Om Maha Saraswatyai Namaha Gurureva Gati Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave Na Guroh Paramam Shishurasmi Guroh Matirasmi Gurau Mam Pahi Guru Jnananandamayan Devam Nirmalaspatikakrutim Adharam Sarva Vidyanam Hayagrivam Upasmahe Shruti Smruti Purananam Alayam Karunalayam Namami Bhagavad Pada Shankaram Loka Shankaram Shankaram Shankaracharyam Keshavam Badarayanam Sutra Bhashya Krutau Vande Bhagavantah Punah Punaha Ishvaro Gururatmeti Murti Veda Vibhagine Vyomavad Vapta Dehaya Dakshina Murtaye Namaha Asatoma Sadgamaya Tamasoma Jyotirgamaya Mrutyorma Amrutangamaya Om Shanti 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 Matrudevo Bhava Pitrudevo Bhava Acharya Devo Bhava Atiti Devo Bhava Om Sahana Vavatu Sahanao Bhunaktu Sahaviryam Karavavahai Tejasvi Navadhitamastu Ma Vidvishavahai Om Shanti 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 Namaskar. Namaskar. Dhanyavada Mahodaya.
Thank you so much. Now, I want to briefly introduce Goutham ji. Goutham ji doesn't need any introduction to all of you. He has been with us every day. He is, in fact, he is the student and also teacher of this course for all the 6 batches and 1 advanced batch and also a batch for the youth and any other. He's a faculty of our this Veda Samskruti Samiti, and he's part of Veda Samskruti Samiti. He is a PhD and he worked in National Informatics Center along with Prabhu Garu, and is very keen on Vedic mathematics and doing research on that. So with this very, very brief introduction, I would request Goutham ji to start the webinar, please. And if I have left out any details on telling about him, I request him also to complement. Thank you.
Namaste, Namaste, Mukherjee Sahib. Thank you.
Thank you.
So, I will straight away go to my presentation. So I will start with this slideshow. I hope the slides are being visible to everyone.
Visible.
So this is the introduction part, and although I have kept the second part also in this same presentation, but I will stop before that. So introduction to Vedic mathematics. My numbers are here. Now origin of counting. So there used to be counting, and so people used to put lines, and how the lines are again combined so that this counting becomes easy. And then first it is seen that Babylonians have some symbol for 10, 100, etc. Because the counting always needed a symbol. The symbols is very important so that something can be, some number of that particular object can be mapped to it, some symbol, like initial symbol was this only line, then it was cut and so on. Then Babylon used the symbols 10, 100, etc. So counting is the basic first foremost discovery in terms of mathematics. Then Roman number system was there. Then it was, you know, that there are few symbols, IV, etc. And we and they denote a particular number, 1, 5, 10, etc. Those things, and they are additive in nature. No multiplication concept is there, so it is some formula is there that if the lower value is placed to the left, then it is subtracted. Like this one actually, DC and VI, you know, VI is 6, but IV is 4. Similarly for others also. And so these still are used as an ordinal number. Now, what is the cardinal and ordinal numbers? Cardinal and ordinal numbers are, one is to say that it is actually the number of counting, where the multiplication, all these things, addition, subtraction, etc. is there. Whereas otherwise, on the other hand, the ordinal number is just to do that leveling something. It is the first, second, third, fourth, etc. So there will be just no addition, subtraction possible. It is just this something fast, something th. So this one number. These are ordinal numbers, and then, like we use this our roll number, PIN, all other number, etc. Those are actually basically this ordinal numbers which cannot be subtracted, or there is no meaning for that. Now, in India, there is a positional number system was first discovered. India was the place where, with all other different countries, use some system, but India used first with in the hands of say quite earlier, and then in recent times, in recent time comparatively, in Aryabhatta, after at 400 AD, they used this called positional number system that is developed, and in 6th century this went up to through Arabia, it went up to Europe. And then it was wrongly told as Arabic number system. But actually, now it is also called Indo-Arabic number system, because anyway, this Arabian has contribution toward that. They also developed certain aspects of that. So 8th century, this became the dominant number system for throughout the. Now, as you know that we all learned this, 1 to 9 was first numbers were denoted. This first was given. After that, it was found that when some place value, there is some called placeholder, I will come to that. So there is no value is there in the placeholder. So the heavy dot was put so that it is not mixed with other numbers. So it is to separate it. So but later that separating symbol heavy dot, but or a circle. So this was a dominant thing and become a zero. So that was called the discovery of zero. Basically, it was just a separating symbol to denote that nothing is there inside. So, so that is the discovery of zero. But actually, discovery was the place value system itself. Zero is just a corollary, just coming as a corollary out of that. And then finally, what happened? The 0 to 9, all these 10 symbols becomes the equal to the base. That is what is most important. The base should be equal to the number of symbols. Then only it can be a good number system. Now, I come to the next slide. And then 0, later on it is found that it came to the part of a calculation. Like that we all know that this something is all these properties of 0 subtracted from 0 addition to 0, and then multiplied by 0, and all the square root of 0 and so on. But the division by 0 is still was not handled by them. It in the 30 in Gunita Samhita, it was also it was not properly handled. Then in 1100 Bhaskara wrongly stated that anything divided by 0 is infinity. But roughly we call that divided by a small thing becomes very large thing. So, but it is actually division by 0 actually is indeterminate in terms of calculus and so on. Later on, it is this concept came fully with the concept of limit in calculus. So, anything say 1 by x tends to 0 is equal to infinity. That is called. That is the full statement. Some of you might have learned calculus. Anyway, the concept of base. The positional number system actually requires a base, and now actually dominant base throughout the world is 10 because it is told that because of 10 fingers it was told that most natural base. And the system of 10 is called this with base is called decimal number system. Number system with 10 as a base is called decimal number system. Various powers of tens are in this called place value or position, or the positional value are denoted by powers of 10. Like the rightmost is the unit, so 10 to the power 0. Next one is 10 unit, then 10, it is 10 to the power 1, then 100, 10 to the power 2, and so on. It goes out like that. For computers, however, the most natural, because it can be like voltage is absent or present. Absence or present of voltage. Either voltage is 0 or voltage is 1. It's called. One means with some value is there. Voltage or current. Then it becomes totally binary, means that either yes or no, like switch on or off. So this kind of things actually more suitable is with base 2. And the 0 and 1 are the symbol, the digits are there. No, there is nothing called digits as 2, 3, 4, etc. And when they are grouped into 2, grouped into 3, becomes octal, and with base 8, and with digits as 0 to 7. This was actually used when octal, a 7-bit called 7-bit computers were in there. But presently, all computers are this 8-bit computer. So this becomes this binary grouped in 4. I mean, sorry, this is 8-bit. So it actually becomes the hexadecimal is the dominant number in that. So it is actually 16 becomes the base, and there are 0 to 9. Those symbols are used from the decimal system, but there also we take help of A, B, C, D, E, and F. The 6 digits, 6 alphabets used as digits with values A for 10, B for 11, and so on, and F for 15, 10 to 15. So these are the details. I slightly went to that. So that to keep the concept of the base. So we will confine in this lecture to base 10 only in decimal system. the concept of place value and face value. Place value in the place value system, these placeholders like unit, 10, 100, etc., those are called the place value. There are actually some people use some other difference, but some definitions. But here I feel more easy to uh, to to distinguish the place value with face value is like that. The placeholder value, like unit, 10, 100, etc., is called place value, and the particular digit that is occupied in this particular position is called the face value. Like, for example, in the say number 756, we have 7 into 100, 5 into 10, and plus 6. This is the calculation. And then 7, 5, 6 are called face values, and 10, 100, and 1 is 100. When unit 10 and 100, these are called place value. Now, negative 10 power place value. It was there actually, but it was discovered somewhere in between. And this is called, as you know, this is called fractions. Basically, 0.34, that means 0.34 is 3 into 10 to the power minus 1. So this place value becomes here negative power place value, say 10 to the power minus 1, 0.1 is the place value there. And similarly, 0.01 is the place value when 10 to the power minus 2. So basically 4 into 10 to the power minus 1, 4 into 0.01, and 3 into 0.1 added to then becomes 0.34. Now, negative face value. These are negative place value, negative power of 10, but negative face value, this is not used normally in conventional or modern mathematics, but these used to be used in Vedic mathematics, so still used in Vedic mathematics. This is called vinculam, and this becomes a tool for different calculation. Any question? Now,
The computer system, can you explain again, please? The calculation. Yeah, last para.
Last part is that the binary always handling a string of 0, 1, 0, 1 becomes very cumbersome. So what happens? Those zeros and ones are grouped into 4. So this becomes a hexadecimal number. This hexadecimal numbers are, say, I can tell you, suppose say 0101 is this number. So 0101 is actually, it is 9, because no, it is 5, sorry, it's 5. 0101 is 5, and 1000, it is actually 8, because 1 into in this 2q, because it's actually basically that in that hexadecimal number, power of 2 is important. So so this number, say 100, 1000, it is 8 actually. So this is it can be 8. So typically, or say 1111, this number. So 1 into 2 to the power 3 plus 1 into 2 square plus 1 into 2 to the power 1 and 1 into 2 to the power 0. So this becomes 15. So these are all numbers denoted, instead of writing all string of 0 and 1, they are written in symbols of 0 to 9, and then A, B, C, D, E, F. Okay. Likewise. Anything more? This is okay? Clear? Because this is the
I don't understand actually. No problem.
I had to put the table. Actually, this it will take some time, so it will eat up some of my time. So I can.
No problem. You can continue, please.
Okay. Thank you. Now, this is a conventional mathematics. Yes. So it is a vinculam was used. Now, there are various states of India use different numerical symbols for 0 and 1, 0 and 1 to 9, and so on. Okay, so these are the they actually handling of those things in computer becomes very difficult. So the hex codes, or I'm going to slightly the mixing with computer, because the Unicode system handles every symbols or every symbol, every alphabet, every number of the whole world. So Unicode is a particular system. Some of you may know. English number doesn't require this. Representation of English number doesn't require this Unicode. This is also ASCII number. So 30 to 39 or 40 decimal 48 to 57 are the kept for numerical symbol 0 to 9. Like there is a, say, a space is 32 in terms of A, capital A is 65 in terms, because those any symbol has to be represented in computer in a particular and stored in a computer. So that is the idea of that. Those of you who understand this thing again. Now this interestingly, this MS Excel sheet, they recognize not only the English alphabet, they also recognize the Indian or other states or other countries, these numerical symbols. Whereas this Chinese, though they do not come under that peculiar, they do not come under that family category, and their numerical symbols are still as a text, so they are not developed much. So to display any symbol, the hex code followed by Alt X, if you do this will be displayed. If you want to write something, I'll tell you. Like these are the, you recognize you are coming from different states, so you will find that your own state symbols, numerical symbols are here listed. Somebody suppose the Telugu numbers are there, and Hindi numbers are also there. So, say for example, how to display on MS Word the this symbol. This is 4. This is 4 of Telugu. I have to write 0C6 and this A, capital A, and put a Alt and X. You hold down the Alt key and then put X. So that will be, this will be displayed. Similarly, for if I do 0C6B, it will be, this will be displayed. So that is the idea given by me. So this is, I don't want to discuss with these symbols. So even this, if you write these symbols there somewhere, and then it can be calculated. Calculation can be done fully, so that some Excel sheet with all the calculations can be done with those, any of these symbols, any number. So it becomes a, always the English don't have to use in states. Similarly, in other countries, there are other numbers: Arabic, Thai, Lao, Tibetan, Myanmar, Ethiopic, and Khmer, and Mongolian. Those are different symbols are there. So those also same can be 0F20, 0F20 or 0F21. So 0 will be here, 0F22 will be here. It's slightly different hex codes of 0. This 0 is at this hex code, but 1 has this one, you have to write 1. Similarly, goes up to 99. There is only one exception here. There is no 0 concept is there in Ethiopic. So there is a peculiar symbol comes here. It is actually one symbol is this one. So after all it comes to, actually it is a hexadecimal. So after 9 you have to go to A, B, C, D and so on. So in case of this one happens. So what is now I come to actual topic. Maybe some time is lost. Vedic mathematics is the institutional use of 16 Vedic sutras. Sutras or formulas, and 32 sub-sutras. The corollaries from those main formulas. Those are also basically 13 are used now. And this comes under from the Atharva Veda Kalpa. And there actually it is found, and but actually this is revived by Jagat Guru Swami Sri Bharati Krishna Ji Maharaj, who did 7 years of deep study. Even there are meditation they do and so on. In Samadhi, it is also some by this time you have learned that many of the knowledge, basic knowledge, be it with this mathematics is a small thing compared to what the Swarupa or the main what is the mind and intellect and Chitra, Buddhi and so on. Those, all these things came in the Samadhi state. all these things, whatever you learned, especially CSR Prabhuji taught you of Upanishad and so on, everything is seen in Samadhi. Similarly, this particular 7 years of deep meditation, Samadhi or study, you can say, this by this Bharati Krishnaji, this actually gave this Vedic mathematics recently, and he wrote a book, and I give you the reference. This Vedic mathematics is a collection of various alternative methods for solving mathematical problems. If practiced, it has potential to develop better control on number system even in school level. So this sometimes some people use in school level quick mathematics and so on. These are learned, but actually nowadays some people are learning basic mathematics in order to pass some competitive exam, because certain certain calculation, arithmetic calculation becomes very fast in basic mathematics. We will all cover that, some of them. And this mathematical intuition comes actually, so that it becomes the solution becomes very clear at times. So always should not mechanically adhere to one procedure in each of these addition, subtraction, etc. Now, this Vedic mathematics book actually is Bharati Krishnaji's book actually. It looks like this, and there is a, later on I'll give a reference to this. I will give the Amazon link. It is available in Amazon. If you search in Amazon Vedic mathematics, you will get this book. It is only 200 rupees or 220 or something like that. Now, this 16 main formulae of sutras or 16 sutras are Ekadikanu Purveno, Nikhilam Navatas Charamagdasta, Urdhva Tirjagabham, etc. These are all goes on like this. In this lecture, we'll first 3 will be covering, and some of them are like in there are the advanced calculations are there. There's some Chalana Kalana means actually calculus. So there are so many Ekonunna Purvana also. You can come to my thing somewhere. So these are all there is a particular meaning of all these things, Sanskrit words, and so this I will come because you can Purvano. These all will come gradually. And there are 13 subsutras or corollaries. They are Ulurupeno and so on. These are this slight expression I had given, whatever I got it actually. Ekadikanu Purvana means one more than the previous. Nikhilam Navatas Charamagdasta means all from 9 and ultimate is from 10. All are subtracted if I do. All are subtracted from 9. The last digit is subtracted from 10 instead of 9. Urdhva Tirjagabham means the upper and slant. To do calculation is upper, up and do vertically, or this slant position. So that is the Urdhva Tirjagabham. This is a multiplication procedure. And Paravarta Judges means transpose and apply. So many other mathematical procedures are there. For each of them, there will be some or other this formulae will be used, and so there will be all of them can be used with different. This is differentiation actually column means. So so many are there. It is not possible to in these 5 days. It is not possible to cover all of these, but actually it's good to know. You can read actually these whatever slides I'm covering. This you please always. You also go through them. If any question comes, my number is there, and whatever I can answer, I can address. Now, this what is the scope of mathematics? Arithmetic computation, multiplication, division, recurring decimals, divisibility. I will cover up to these, and there are highest common factors, then square root, cube root, etc. Equation, then factorization and differentiation and integration. Those various scopes are there. You can all written given in the book. Those of you are interested, you can go through the chapters of this book. I will cover in this lecture of 5 days only up to divisibility. Now come to arithmetic computation. These rules of addition, subtraction, multiplication, division, which are we use always. Since school we are learning those, we have learned, and these all have some or other algebraic background in them. We do not always concentrate on the algebra content, but actually there is algebraic background. Why we in the division, why you do like this, first you multiply and then put it there, you subtract there, and so on. Everything has an algebra behind that. Now if the inherent algebra is changed, the procedure also will automatically change. That is the idea. This basic mathematics doesn't want us to get stuck with only one method, one background algebra. But if we use different background algebra, as and when it is required, it becomes more easy. The easiest process. If we learn different procedures, then we see a problem, a mathematical problem, or arithmetic problem. Then we can easily understand which is the best algebra to be used, and obviously the best procedure connected to that algebra. In this session, we shall learn some such alternative procedures in basic mathematics, both positive and negative. This is I'm talking of influx. In basic mathematics, both positive and negative phase values can be used for digits more than 5. Use of negative phase value called vinculum notation reduces the calculation effort. For example, 48 can be expressed as 5 and with 2 vinculum. Vinculum is a one bar above. So basically it denotes negative, means negative 2. So it becomes that 4 into 10 plus 8, it becomes 5 into 10 minus 2. It results in the same number. So that is the idea of the vinculum. I will come to it repeatedly. And now I come in detail in concept of vinculum. A number with a bar above is called vinculum in notation in Vedic mathematics, and this denotes actually negative phase value. Now here he wrote something actually. Unfortunately, in Unicode, so many things are there, but I do not find. There are some numbers with a circle is there. There are numbers with dot above is there, but unfortunately there is nothing called number with a bar above. Then it would have been good to represent. Now I had to do all with some other method. It may fail sometimes. It is by picture. So I come to that subject. 6 is equal to 10 minus 4. So 6 can be represented as 1 and 4 with a vinculum. 6 is a small number, it is not, sometimes we do not notice. So 97, for example. It is 100 minus 3, so it is actually like this. 1, 0 and 3 bar above. So it becomes actually 1 into 100 plus 0 into 10 plus minus 3 into 1. When it becomes 1 into minus 3. 1 into minus 3. So or minus 3 into 1, whatever it is. So 143 143 above vinculum. 143 0 0 0 143 142857 is the result, because 143 into 1000 plus becomes minus 143, because everything is bar, so it is minus 143. So similarly, 289 is equal to 300 minus 11, so it is 3 and 11 bar above. So this becomes 3 and 1, 3, 2, 4, 4. All these things are above. So this becomes this number. Now, here the formula being used, we don't have to always split it like this. This is actually algebra, but actually we can use that as procedure, which is called Nikilam Navatas Charamang Dasata. Whenever there is something else, vinculum is on the total of that, we say 143. Out of it 143. So I will subtract 1 and 4 from 9. Nikilam Navata. But I will subtract 3 from 10. Charamang Dasata. Charamang, ultimate of this particular vinculum series, up to particular vinculum continuation. So like here also, all three, 1, 3, 2, 4, 4. Here 1, 3, 2, 4. These will be subtracted from 9, and last 4 will be subtracted from 10. So this becomes, and this becomes Eko Nunnenu Purvena. This whenever I want to transform from vinculant to actual number, we have to reduce. Basically, this comes from this algebra. So why you reduce? But actually, mechanically, you can do as the procedure is that reduce this 3 to 2, and then subtract all this from 9, and last one is from 10. This becomes 86756. Is it clear? On the other hand, suppose this number we have to convert to a vinculam, because these are all, you see, all these are all above 5. So we have to better to handle it with converting them in vinculam. Then what do you do? Ekadhikono purveno. I do it. This 2 becomes 3, and then all these things subtract from 9. 8 is subtracted from 9. 8, 6, 7, 5. These are subtracted from 9 each. But last one, 6 is subtracted from 10 to give. So this thing itself, you can learn how to apply from vinculam to, you can convert to non-vinculam, and non-vinculam to convert vinculam. So you just see it and in practice, so you will get it, and also check the algebra, so you'll get that how there will be no confusion in converting vinculam to non-vinculam. Now, why the sign actually is this becomes right above. I repeated here. Normally, this vinculum requires only 5 into 5 table when you use proper. So this I have tried to write vinculum, but it's not coming. This is through Unicode you can write it, but it doesn't become that much successful actually, unfortunately. So I used another method of writing in this particular presentation. Now, what is that? I come to the application of vinculum. Suppose you have to add all these numbers. Those are all numbers here. I put all above 5, 8, 9, 7, and so on. Have to do a lot of efforts in adding those things. You have to do always carry and so on. You can do it. These are only 4 numbers. There can be many more numbers. So vinculum, if we convert into vinculum, this becomes ekadhikono purveno, 3 becomes 4, and then this nikhilam navatas charmang dasata, 9 is subtracted from 9 to give 0, and so on. So 6, 7 becomes 3, 2. Here vinculum 3, vinculum 2. When more than one are vinculum, you can write continuous vinculum. So this is understood. And 8 is subtracted from 10, so it becomes 2. That way, all these are converted into vinculum. We add this, now this becomes less than 5, so it becomes easy to, as a result of addition, it may become vinculum. More than 5, that cannot be avoided. So this 2 plus 3 plus 3 becomes 8. They all added to 6, and this becomes 4. This becomes 6. So everything was more than 5. So more than 5, so it becomes ultimately this one. And then when you convert it into non-vinculum, what happens? Again, 14 becomes 13, and these are subtracted from 9, 6, 4, and 6, 3, 5, 3 becomes, and then 8 subtracted from 10 to give you 2. So expression in the background. So this we use as a procedure. In this whole thing, this whatever you see in these 2 columns on the left, this comes as a procedure, whereas this is the explanation of that. So explanation is this one. So we basically added these things, and they subtracted and becomes like this. So these are only one kind of things are there, or everything was more than 5. Suppose there can be another problem, another kind of problem, or this one, this I have shown. The next one is this one. See here, I chose particular kind of number where It is alternatively it will be vinculum or non-vinculum why is adding. Then we'll see that main application or the more it will be how it is coming using the calculation. So 3, 9 becomes 4 and vinculum 1. So 39, 3 into 10 plus 9, or it is 4 into 10 minus 1. So that is 4 and vinculum 1. Or Nikilam Navatas Charamodasata Charam is only there is nothing called Nikilam Navata. Charamodasata, only one is there, so it is Charamodasata only. So and Ekadikano or Ekadino as it comes, Ekadikano come here. So 4 and 1. And then 27 becomes 3 and vinculum 3, then 4. Similarly, all are converted like this. So the problem I have chosen, so it becomes negative and positive. So 4 minus 1 plus 2 minus 4 becomes 1. Minus 3 plus 5 minus 4 plus 3 becomes 1. So that way, everything can be done. And directly we got to, that doesn't come any negative number, not vinculum. So it came to, directly came to the number. Here the expression becomes a little tricky because these are actually crossed like that sometimes that these are actually, this part I have crossed it actually. So it becomes like this. So you can see later in details. So the idea is to convert it, whatever is more than 5 is there, we convert it into vinculum there. More than, and at times even equal to 5, because actually something is more than 5 is there after 5, effectively that value of 5 becomes, you have to also convert that 5 also. You automatically get converted, otherwise it will, somewhere it will be more than 5 again. So this is the idea. You can see it at leisure sometimes and try to, if you do not get it, I can again come. It is the idea that we show that here actually it got cancelled, and it becomes easier, small. Now there are certain small ideas you by basic mathematics. Sometimes people use various tricks. Tricks looking, but actually there is algebra in each of them. So sometimes actually there is a procedure called something more than 5 and the end, 2-digit or 3-digit number like that with ending in 5. What to do? That is told that here you do only 1 into 2 and then you do 5 into 5. So 225, like 35 square. This multiplied by ekadikane of that, multiplied with that, 3 into 4, and then 25. So 25, 5 into 5, 25. So 1225. 45 square, 4 into 5, then 25. 20, 25. Like this. So this is the good shortcuts of that. And not only this, if they added to 10, like I didn't show it, like if you, I can show you. (73 into 77 for example. Here also it becomes 7 into 8 and then 3 into 7. Because 3 plus 7, this 3 plus 7 is 10. So this can be done. So it becomes 5, 6. You can please check. 56, 5, 6, 2, 1. Is it correct? Anybody? So this becomes say one digits are, earlier digits are same. Last digit actually added to 10. So this becomes actually same procedure can be applied. Anyway. Now we come to multiplication near a base. How much time? Multiplication near a base. Any question from the whatever I have discussed so far?
You're all open. You can ask your questions.
Numbers to be added. How you converted those number to Hanculus? Can you please repeat it?
Yeah. This one should I give from the here? See,
Yes.
39.
How you converted that 39274 in 41334? That's my question.
No,
Sir,
it is not. It is not 41234. 39274. It is 4 vinculum 1, 3 vinculum 3, and 4.
one doubt, sir. When you're adding, you have to make the highest round off number, isn't it? First,
Which one?
when you add, you have to make the highest round off number. Like 39 will become 40, isn't it? When you add, then 40 minus 1 vinculum 1. Is
Yeah.
it like that?
Yes,
Why
yes.
you always take two numbers? If it is second digit is more than 5, if it is less than 5, it should be taken only one digit, or what? What is the principle? I couldn't understand. Say like that 39 is second digit is more than 5. So you take the higher, it will be 40. 40 minus 1 it will. Whereas 53, it is second digit is less than 3. So you are taking only one digit, 5, and going for the 37 next to two numbers. What is the rationale?
This is actually 5. We need not convert it. This 5 need not be converted to 5. You are
Why?
right.
Why?
Because it is less than 5, no? Less than or equal to 5.
Second digit is less than 5. That's why you take only single digit.
The second, you mean to say this one?
Yeah. Say 53, when you take from the left, 53, second digit is 3. 3 is less than 5. So you take only 5, and 3 you add.
No, not that. Here you are not, will not consider 53. Each is individually has to be considered. That 3 is actually 3 is less than 3, less than 5. So don't have to do anything. But 7 is more than 5. Whenever, so therefore 7 has to be converted. So that will affect the previous one.
Okay.
That is the previous. We do not consider in groups of 2. But wherever something is, I first suppose I first denote that the following these numbers are more than 5. This is more than 5. This is more than 5. And this is here. This is more than 5, and this is more than 5. This is more than 5. These are. I first denote all this, which is more than 5. Then I know that this has to be converted into vinculum, and that will affect the previous one. Suppose the first number like this, if the first number is suppose here. No, this I didn't give that example. Anyway, so suppose some number starts with this one, more than 5. Had it been like say 99274. Okay.
Yes, 99 will become 100 vinculum 1.
Yeah, exactly. Then you have to do like this: 1 0 0.
30 vinculum 1. 30 vinculum 30 vinculum.
Like this one. So this becomes like this will continue like that. Okay. So
Yeah, I think this method will fail if all the last digits are 6, for example. So you'll convert all of them to vinculum and they'll become 4. 4 times 4 is 16. So you have a carry there. You're trying to avoid the carry. So I think
no,
you have
not always you can carry. Multiplication you're telling.
No. For example, in the
Always
numbers to add,
avoid the carry. Carry can be there. There'll be a method to handle that carry also. We'll come to that. Multiplication it didn't come till only addition. Okay.
no, if all the digits are 4 on the left-hand side numbers, and we take vinculum, let's say all the okay, let's say the last digits of all the 4 numbers that you have shown, like 39274 and 53749. If the last digit, all of them is 6, and you take vinculum, then on the vinculum side, you will have 4s. All of them will be 4 vinculum. Now you add all of them, it will be minus 16. Now what do you do with minus 16?
Mean to say what you told, that it is 4 and 666?
No. Suppose if the numbers are 39276, 53746, 28366, and 438626. So now all those 6 on the last digit will get converted to vinculum 4 on the
Oh,
vinculum.
vinculum 4. Yes.
Yeah. Now if you add all the vinculum 4, it will be more than there will be carry.
It will be. It will come to that. Then it will. There will be carry. Carry has to be added.
Okay.
Carry will be there. No, carry can be there.
So the carries are on both the sides, then how do we know which is better then? Carries on both the sides. If you just add, I don't know.
It will be this adding 4 numbers of 6 will be 24. It will be more carry actually. So this is actually averages out, and then it will be, we find that finally this is the less. Carry will be there. Carry if the numbers are more, you cannot avoid carry.
Yeah, I'm not sure. I
There,
mean, the
there
process
is
should be.
another procedure is there for addition. I can cover. There is another procedure by which you carry do it in another way. This carry can, there is a carry cannot be avoided. Carry can never be avoided.
No, but the whole thing was because carry is there.
No. That didn't mean that. It will be easier actually when you say. Adding the 6 numbers of 4 numbers of 6 and adding 4 numbers of 4. Obviously, adding 4 numbers of 4 will be easier, no? That is the idea.
Is one method that is if more than if 2 numbers added 10 it becomes more than 10, make a bar and carry only 2 and go on adding the higher numbers. That will be easy, rather than vinculum system.
You can try these things. You can better you exactly give the number problem. I will tell you. This can be there. I mean, all things you try first and see that how the. I always use the proper formula and you do it correctly, you'll find that the using vinculum becomes easier.
Okay. That means you need some more practice to do this.
Yeah. This, yes.
So practice, you cannot find out which one is easier.
So that it comes with experience. I gave the way only. So problem money giving the problem, it will, you have to design the you have to see it how it is working the best. Yeah.
One more thing, square root. Square, can you make out square slide?
Oh, squaring. Yeah.
I want to ask you, if it is first tens position, if it is 3 into 2, 6, 6 into 6 you should take, isn't it?
Huh? Which one?
35. 3 into 6 into 2. Or what is the method? I couldn't understand. 1 into 2, 2 into 2, it will be 2 or what?
No, 3 into 4.
That means
This,
any number
for
into
3 I am using 3 into 4, and for 5 it is just writing 25, means 5 into 5.
What
So
about 12?
This 12 into 13 is 12. This 12 into 13. And
How?
Then 25.
13, 12 into y 13. Y 13.
It actually coming from algebra. This procedure is coming from algebra. So we have to write, multiply this number with the next number. Means 12 into 13.
Okay. Like this, 3 next number is 4. 3 into 4. 12 next number, 12 into 13. 122. Next number 122 into 130, 123. Then 5, simply 5 square 25. Is it?
Exactly.
Now it's easier.
So for 5 into for each 5 you have to write only 25 in the.
This is very easy. 33 is 30 into 31 plus next number is 25.
Not plus actually, we just write in the side.
Next number is 25.
So this algebra is actually here.
square is very easy now.
Yes, yes. Thank you. Now I am coming to multiplication.
Excuse me. That
Ah.
see, they how to really multiply these 3 digits, like 1302 into 303. Do you have any easy
Yeah.
way of
That I'm coming, because basically this is the multiplication procedure now. So this is multiplication. First I come to near a base and below a base. So like the base is actually always base. This is by base in the this multiplication. You always denote power of 10. Base is equal to power of 10 basically. Okay. Base is equal to power of 10 power. Some 10 to the power something. 10 to the power 10. Power of 10. So 97, 93. Which is the nearest 10 to the power 10 power here? It is 100.
10 square.
Exactly. 10 square. 100 is the nearest 10. The nearest is 10. Now how much it is short from
3.
3 short. But it is actually, because it is 100 is the base. So what I do, I keep the same number of zeros there, number of zeros as the, so you maintain that number of zeros are 2. So I have to maintain this 2 digits. So becomes, instead of -3, I write -03. Similarly, 93, we write -07.
Yes.
Now simply what I do, what is the multiplication procedure? I do 97 minus this 7 or 93 minus this 3, becomes obviously it will be same. It is 90. And then simply multiply this 3 into 7. It's 20.
No,
So this,
please, can you make a calculation and show?
yeah, 97 into 93. You use calculator also. I didn't. I ask you to do calculator. You can. You have paper, pen, everything. No, you're carrying. You just do it. Verify it.
Yes.
In calculator also it will be. You can see it. Verify.
It will be 97 will be 100 minus 100 vinculum 3.
Suppose I do another one. Say 80. 89.
Okay.
Into
90,
say
91 column 1.
91.
Huh?
And this becomes point minus 1, isn't it? And this is minus 0.9.
I don't know.
89 is minus 1.
That means you are taking from 100.
Subtracting from 100.
Okay.
And this is 91 is minus 0.9.
Yes. Okay.
So
now
89 minus 9 is 80. Or 91 minus this thing. 91 minus 11. 80. And this 11 into 9 is 99. This is the answer.
Sir, excuse me, sir, you have taken 8, like previous example, we have 96 here. So you have taken 89, 91, you have taken 80. Why can't we take 90?
No, I subtract from 100, or you can do that Nikilam Navatasarma. 8 I am subtracting from 9, and 90 I am subtracting from 10. So it becomes 1. You do another one.
That I got it. 89 minus 11 you got from 100. When you do 100 minus 11, you get 89.
Yes.
100 minus 91, you
Base
get 9.
is 100. Base is 100.
cross 89 diagonally opposite 9. You have to take.
Cross. The subtraction will be cross. The 89 minus 9 or 91 minus 11. And both are same.
Okay.
Thank you.
Okay. So you can try with various numbers.
Yes.
I gave the smallest number so that it becomes easier. But actually, I could have done this also. Sometimes it will be more than this digit. That will be again. You will find that it is. Suppose I do. Anyway, I can show it later. Then carry, how to handle the carry. Now again, I'm basically I may change also later these ones. It's too small, too easy it looking. Just to this was just to give the concept that these are the looking very big, very horrible, big numbers. You have to do a lot of work with multiplying this with this. But here, how it becomes easy? That is the idea. So 99, somebody's speaker is on actually. So this there's the background noise. Can you switch it? Acha, 997. Whenever you want to speak something, please switch it on and then again switch it on. And 997 becomes the number of zeros are again the base number of zeros are 3. So to do 3 digits have to preserve. Minus 003 minus 007. Again you do that 997 minus 007 becomes 990 and again 3 into 7 becomes, now we have to also preserve the number of digits, so it is 02. Similarly this one. Here I give another example, 9876 into 9987. It is 0124. Nikhilam Navatashtana 9 minus 9, 9 minus 8, 9 minus 7, and 10 minus 6. So 0124. Similarly, 9987 is 0313. And this we multiply by, you can follow other methods, and this method, it will be another, you have to write. And then all you can do directly by method, it become 1612. And this also 9876 minus 13 is 98663. This becomes my answer. Now, if you consider these two, if we compare with this one, compare this one with the next two, similarly, we will find that number of increasing more nines becomes addition of 1 9 in the left part and 1 0 in the next part. Suppose I do this one now. Simply I do, there is suppose the problem was like this. So obviously I will put more 0 here, 1 more 0 I will put here, put the 9 here, 1 more 0 I put here, 9 here. Obviously in the result also 1 9 will be added here and 1 0 will be added here. Similarly, if we do like this here and here, so this will be 1 0 will be here, 1 0 will be here, minus. So here 1 9 will be added here and 1 0 will be added here. So this is why you can totally visualize that system, how this is working. This comes from a very easy example, this algebra.
ये 10,000 वाला में 16 कैसा आया साहब? बेस 10,000 है ना? 4 शून्य में वो नीचे 1612 कैसा आया?
124 into 13 is 161. This one I'm telling. The 13 into 4 is 52. 13 into 2 is 26 plus 5 is 31. And 13 into 1 plus 3 is 16. So 16, 12. You are asking this?
Yes, sir. Like I thought you have some simplified calculation for this.
No. Then for that you have to do again that 100 plus 24. This should be difficult.
I understand. Thank you.
It cannot be possible. Cannot be done in this procedure. Acha. Now the algebra behind this. Algebra behind is this. N minus a into n minus b. So suppose this is n. This base is my n. Now this is already n minus a. What is a is this 3 and b is this 7. So this given numbers were n minus a into n minus b. So what I do? I do n minus a into b, n minus a minus b. So this becomes, because this cross subtraction, by cross subtraction, I am getting this one, which is n minus a minus b. We are multiplying this by n, base. So shift it towards these 3 digits. It is shifted. And then I add with ab, the multiplication of this. So is it correct? Is it correct? So become basically 990 into 1000 plus 21. It becomes. Okay. So this is the algebra behind this. Using this modified algebra, I modified the procedure. Multiplication procedure is given. Multiplication procedure now uses this algebra, this particular algebra. Which, whereas our conventional mathematics doesn't use this kind of algebra. So as a result, there will be a lot of calculation will be needed for that. First, you multiply these 3 with all these things, shift it, multiply the whole thing with 9, and again shift it, multiply with 7, then finally add these things. So much procedure has to be used. But here, just by locating, just by realizing that these are numbers which are coming near to a base, you simply change the algebra on that and then follow this procedure and becomes very easy, very transparent.
Did they use abacus in Vedic times, or because
No. Abacus, I have not learned, but I've seen. I mean, I think this consideration of number doesn't need an abacus. Also, abacus also is some instrument, and then you do by your fingers, and you may be very expert. But if you can find the same kind of, you can attend the same kind of expertise using mathematics.
No, my
Okay.
question is, is there any evidence of using of
No,
abacus in Vedic
abacus,
time?
abacus, no, there is no evidence of using an abacus and so on. These are actually this simply by algebraic consideration and converting that new algebra, another algebra into a procedure. Algebra to procedure, it becomes a procedure. So now we come to near the base, but it's above. It is similar. It's like instead of this -3 and -7, it was +3 and +7. Exactly the same way you do. Now you do add this thing, cross add 110 and becomes 21. So this becomes my answer.
Sir, if there is a number, it is near to 100, we are talking. Like we are talking like when it is near to 100, like 80, 90. If it goes to 60, like 64 into 66, can we use this principle?
If it is more away from the base, there will be this procedure will be complicated. So therefore, we will use some other procedure. That is, these are the near base. Okay. Okay. Now there is higher basis like this same I did here. These are same example. We find that increasing number of zeros becomes in the multiplication results in addition of same number of zeros in the first part and same number of zeros in the second part. If more zeros are there, it will be more zeros here, more zeros, there will be more zero here and more zero here. So likewise, so suppose I take this example, 1 0 1 to 3 becomes plus 1 to 3 and 1 so many zeros 5 becomes 0, 5. Base is 10,000. So this plus this is 10128 and this into this is 615, 0615. So this becomes my answer. So the algebraic expression is this n plus 1. This is this is A and this is B. This was my n plus A. This was my n plus B. I did n plus A plus B because I cross added. So n plus n A plus B, and I shifted these many digits. So this is multiplication with the 9, and then becomes I added this thing multiplication of these two with A and B, this AB. So this also this algebra is translated into a procedure. Now it is mixed. One is less than in the base, and one is above base. How to do? This is minus. This is actually 93 is minus 0.7, and 107 is plus 0.7. When I multiply this, it becomes negative. We put it in vinculum. So it becomes 93 plus 7 is 100, or 107 minus 7 is 100. So it becomes 100 and 49. 49 vinculum. So if we do niculam namatasya, it becomes finally answer becomes 995. So if you can write like this, initially you write like this 100 and then 49 with vinculum. Nikilam Navata, say 100 becomes 99, and then Nikilam Navata 9 minus 4 is 5, and 10 minus 9 is. So this is the idea. So I give more example. 113, 1013 into 993. So this is plus 0013 and minus 007 becomes 091 on vinculum, and 1013 minus 7 is 1006, all or this also. And then finally this 91, this becomes 106 becomes 100, it's 1006 becomes 1005, and then 091, this becomes 9 minus 9, 9 minus 9 minus 0, 9 minus 9, and 10 minus 1, 909. So similarly, this one 997, and you can try 99956 becomes 9995, and this 0021 becomes 9979. So this becomes the answer. This becomes the answer with this procedure. So if we mix it like the same algebra, 9 plus a, this is A and this is B. 13 is A and 7 is B. So n plus A, n minus B. So n plus A minus B. So when I do cross, this cross procedure, I just cross subtraction here or cross add here, becomes n plus A minus B. We shift it to this many procedure, this many digits, this is a multiplication of by n, and then minus AB. So minus AB is the result of it. We put it into vinculum. AB is put in vinculum first, and then you subtract it. Right. Now comes this sub base, which is not near a base, but near a some either multiplication or a fraction of the base. Suppose I come to this one, these two numbers, 483 and 497. I find that those are near 500. So what do you do? I exactly follow the procedure as if I am subtracting from 500. 483 minus 483 is minus 017. So my sub base is 500. So I do from sub base. So 497 minus 003 becomes actually the left part becomes same. Here also I do initially I write 480 because 483 minus 003 is 480. Then finally what you do? This base is actually our 500 is actually, so 1000 divided by 2. So this is you have to infer. It is divided by 2. I do divided by 2. So it becomes 240 and then becomes 240051 is my answer. Or I can take 500. I can consider it as a 5 times of my base of 100. So similarly, I do if at 100 the number of zeros are only 2, so I do not have to keep the extra 0 here. So 483 is becomes minus 17. This becomes minus 03. I subtract, it becomes 480, and then this becomes 51. But now I multiply by 5 because my 500 is 100 multiplied by 5 becomes my 500 sub base. So therefore, you multiply by 5 comes to, obviously will come to the same in a different. So similarly, I come to that above sub base. This is above sub base. I come to that. I again divide it by 2. I here also I did it like this, and I divide and multiply by, if I consider this base as 100, I multiply by 5, and finally I come to same result. Sorry. Is it correct? Is it clear? The sub-base concept? Anyone?
Sir, I have now 107 into 93 in the previous second slide. Like if you go to previously, for this also.
This one?
103 and 97, like before this. Previously, when we started, na, sub base, like the numbers are not equal, like 100 and 90. previous to this slide.
No, not this one, no?
Not
Sub-base.
this one. Previous. Again, you go to previous back.
Oh, back from this one. This one.
Yeah, back. Yeah, back. Sir. Yeah,
This
this
one?
two. Yeah, sir. 9cc and 7. Yeah, this one, sir. 9cc and 7. Like here, I was having reps like we got 7749. Again, we got 97, 9cc plus 700. So after that, again, we got 9951. So, like again, we are subtracting 49 from the 1000.
This 10,000 I'm subtracting basically.
Okay, fine. No, I thought like in the previous example, we directly took the answer. Now here again, we are subtracting.
Because here it came vinculum. One is positive, and is negative. So it becomes vinculum. No, therefore you have to do some procedure. You have to release that vinculum. So that's what it happens.
The formula is same. Like when the digits are equal.
Formula is same. Formula is same. One is positive, one is negative. So if we do it by algebra, that's also fine, and all Nikilam Navata Starama Kasata will give the same result. Okay. That is the idea.
Thank you, sir.
This actually, this instead of using conventional mathematics and using the algebra, here we are directly changing the procedure, because there is nothing that particular procedures of subtraction, division, multiplication we have learned, that has nothing unique in that. That can be an alternative procedure. That's all I would say. That always don't have to use this algebra and use your conventional mathematics. It is not required. You change your procedure, okay, so that it becomes easier in one go. So that now it is like this. I subtract. I did with sub-base. Here is above sub-base I was talking. Here also you can either do 1000 or 100, and then there can be mixed also. Like then also there will be procedure. So this 483 is minus 0.7, 0.17 from 500. 507 is plus 0.07. Here you write 490 and then 119 becomes negative. So it becomes dividing by 2, it becomes 245 and then 119. So 245, 119, 24, this one is reduced. 245, 244 becomes, and then it becomes 8, 8 and 1. It becomes 8, 8, 1. Or if
it's 500 and 017 and 507, so if there are both are 5, like here we got one is 5 and one is 4, we have used the same procedure, right?
Yeah, one is above base and another is below base.
Okay.
Now here also, if we do like this, preserve the less number of digits here, the base 100. Here, what happens? It doesn't fit here actually. This vinculum doesn't fit here. There is a carry. This carry we write in the short form. This carry actually is added. So when you after you multiply by 5 becomes 2450. This one carry is added to this, so it becomes 2451. Finally come to this one. When I'm sorry, this in this case it will be subtracted with this because this is negative. This is negative 100, so it becomes subtracted to becomes 2449. 2449 again because 19 is also negative, so it becomes 881. So actually this way you have to do.
Sir, if you could suggest a book like where we can see all this.
These books I have shown you. I'll give you the in Amazon you can do Vedic mathematics by Bharati Krishna Tirthaji Maharaj. Okay.
Okay, sir. If you could send us the name of the book in the, if you'll keep in the group.
Sorry, I'm not carrying the book somehow. I'm in a different room, and I've shown in one of the slides. I've shown you the book.
Okay, sir, not an issue, but you can name of the book and the slides we can bring.
It is given in the first slides. When you watch the video, we will get it. Okay, we will go on.
One of the slides is given. So now it is again another example is sub base. Always cannot be 500. 250 also can be a sub base. So 235 and into 247 becomes minus 015 and 003. This I am now dividing multiply by dividing by 4, 58 and 045. Now there are various challenges may come. Dividing by 2 or dividing by 4 becomes fraction may come. How to handle that fraction? Like 18 into 45, base 100 becomes sub base becomes 50. So 18 is minus 32 from sub base 50 and 45 is minus 0.5. This becomes 160. So 160 cannot fit here. So one is put it carry is 6.5, 160, 6.5. This half in 100 position contribute 50 in the tens position. So this becomes this basically 600 plus this 50 plus this 160 ultimately comes to 810. So you can do this. There's some logic behind this one. And now, what is the sub base concept? What is the algebra? What is the algebra expression of this?
Yeah, Gautam ji, sorry for interrupting you. We have the Prardhana time now. So after the Prardhana, we can continue as per Dr. Bhav. So we
Just
now
let
have
me finish the algebra only to continue after that action. The algebra of this sub base concept is that, so this is, suppose the sub base is there 500. So this half is carried with this. So this half into 1,000 is this is 500. Half into m is half here. So 500 minus a and 500 minus b. So 500 into this 500 minus a minus b. So this is actually base shifting and then dividing it. So this is this m is half here. So this is the idea. Okay, I stop here, then personal and so on. Namaskar. I can continue it after that. Okay.
Okay, thank you. Thank you, Gautam ji.
Namaskar. Thank you.
You want to continue after Pradhana, no? Yeah. I'm stopping this sharing. Now we go for Pradhana. Sharda ji,
Yes, sir.
please.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीमहीषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथ्वी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अदना सदना सन्तु जीवन्तु शरदां शतम् सत्यं वद धर्मं चर मा स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः स्वस्तिः
धन्यवाद.
नमस्कारः.
Now we'll go for national anthem. Challa Chittibabu garu.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाहे तब जय गाथा। जनगण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे। जय हिंद जय हिंद।
జై హింద్. ధన్యవాదములండి చలా చిట్టిబాబు గారు.
धन्यवाद.
Now, are you going to teach now or what? Question answers. What? How do you want to proceed, Goutham ji?
Better to do question answer now. One part I have completed, so tomorrow I can start a separate part. So this as a reference, I will start the presentation here again. With the reference to that, I can answer certain questions.
Yeah, this reference of this book is also given in the manual. People can refer to that.
Yeah, this is the book.
Sir, one request. Can you put all the slides of only calculations? And better if you step by step each addition, division, multiplication, all the steps if you include, it will be easier for us to understand and remember.
Which one?
Like addition you are doing, no? 197 is equal to 100 minus 3, like that. Then how to go next step, stepwise. Because if you tell him fast, we are not able to understand and absorb properly.
Which one? This 97. This one.
Then what is the next step? 7 into 7, 49. Okay, then what is the next previous 100? How it will connect?
Oh, 93 plus 7 is 100.
Okay.
Or
Okay.
107 minus 7. Actually, I have already discussed this earlier. So this is the, you want to say that is the same procedure.
No, but
I started with this one now. I started with this one.
Sir,
I told
I'm saying we need
the next
process.
one. 87 into 85. Can you tell me how to do?
87.
85.
87 into 85. Tell me how much it is less than this 100.
100 minus 13. 87 is.
Yes. And this one?
100 minus 15.
15.
So 13 into 5 you have to do.
13 into 15.
15. 15.
So it is 195.
195. Yes. Then next 100 you have to.
This becomes 195. This becomes actually this is the next step. So I didn't put these examples. These also because each of them will take some time. Here a carry you have to do one. Write one here. Then 87 minus 15 is how much?
87 minus 15 is 72.
22. Okay. This carry you have to add here.
Okay.
So answer becomes now 7395. You can just verify.
So it's not the general rule to what you have explained nearby 100 and less than 90, 70 like that. Different rule.
No, this is not different rule. This is the same rule, except there is a carry, so we have to handle that carry. That's all.
Okay then.
Sir, when we need to consider carries, like the previous example, 97 and 93, here we see 3721. Okay, when you are getting 6 digits, you only need to carry. You are getting only 2 digits, then we need to continue with the
see, the same number, suppose it is 987 and this is 985. Okay, this becomes then 0 minus 013 minus 015 minus 015. In that case, it will be this 972, and then it will be 195 directly, like this. One will be here then.
So what I understood from here is you mean to say that like 97
Even
like
if it doesn't fit there, then you have to put that carry below, because it is not fitting. There is only 2 digits allocated because the base was 100, and the 2 digits allocated for that, but it is 195. Result is 195, so it cannot be, fit in fit in 2 digits. So one has to be added there. But otherwise, if it is fitting there, 195
no need.
becomes, then it is
No need.
the right side by side. Okay. Whenever there is the result of the multiplication doesn't fit there, that becomes a carry and that has to be added. Okay. Any more question? Achha, that is the thing.
If there are no questions, then for today we will close.
Now one more. This I went up to this one. Okay. Now tomorrow I will cover this Uddhoti Jagapan. Okay. Today actually this particular multiplication near base or sub base are complete. Now here there is a, should this require some elaboration? This how to handle this half, how it came like this.
We will do that elaboration tomorrow.
Okay.
But today, if there are no questions, then we will close.
Okay.
There's just one question, actually, one request.
Yeah.
If you can cover, on the beginning, actually, on the first slide, I saw that you mentioned differentiation and integration. If we can cover that, that will be helpful, because these days the AI systems, they use chain rule to update the model parameters, and that is basically differentiation. So if you can speed up that, then a lot of energy will be saved, because training AI takes a lot of power. So I just I'm kind of curious about that. If that is there in the book, then I can refer to the book, but it'll be helpful.
Actually, that is one of the work. Even I was studying that, and that is I kept in the second course actually.
Okay, thank you.
That is kept in the second course. In today's this 5 sessions we cannot cover that one. But if you are interested, you kindly put me in WhatsApp. In the first slide I gave you my number. So if you are quite advanced in that, we can talk individually.
Okay, sound good. Thank you very much.
Sir, if you could suggest a book for this, because like integration differentiation, right? So if you could suggest a book.
That Bharati Krishna Tirthaji's book is there. You just can you use your mobile and see this number, this is coming, this book. It will come. It will come in the very first book. The first entity is there. There are other books of course. There are other books of.
Okay, sir.
There are other books of Vedic mathematics, but this comes always in the top. You just try.
Okay.
Just now.
Okay.
Use your mobile. You will see that the Bharati Krishna Tirthaji. This will come in the first actually. Jagat Guru Swami Sri Bharati Krishna Tirthaji.
Yeah, it is available on Amazon.
Amazon. You open Amazon and you will find it. It is 200 something.
Okay, sir.
Any other? If no other questions, then we'll try and close now. Somebody has put Rameshri Garu
Okay, sir.
also. Yeah, it is available in the email.
Yeah, it's available.
Shall we
Please
close
share
now?
your phone number. Yeah, that's it.
Phone number?
Yeah.
98300 23 972.
Thank you.
Okay, then.
Shall we close?
Okay.
Okay.